Okay, so that's the chapter 7, internal forces, and we are doing the diagrams of the shearing force and the bending moment. And it's a bonus problem, just to see the impact of this moment that is added in the middle there. Okay, and here, forget about the fact that we can move a moment anywhere. No, we can't when we look at internal loads. Okay, if we move this moment where it's applied, so not there, but there, it will not be the same graph for the moment. Okay, so what step 1, find the reaction force. Okay. And I thought we will cut the diagrams. Okay, so we have a y, a x, if we look at the pin connection, and n, b. We need to replace this load by just one resultant force, and the resultant force is equal to 10 times 2, so 20 kilonewton, and the location is 1 meter from B, okay, or 1 meter from this point. When we do sum of the forces on x, it's equal to 0. We found that ax is equal to 0. There we go. When we do sum of the moment about B, it's equal to 0. We find, so we do the moment about B. Ay minus Ay time the total of the length. So 2 plus 1 plus 1 plus 2. It's 6. Minus plus the 15 kilonewton time 1 plus 1 plus 2. 4. Minus this 20 kilonewton time meter. No distance. It's already a moment. And plus the Fr time 1 meter. It's equal to 0. So we have 6 times Ay, that is equal to 15 times 4, 60, minus 20, plus Fr, that is equal to 20. So Ay is equal to 60 kilonewton. Oops, 60. And if we do sum of the forces on the y, it's equal to 0. We have Ay. Just try. Oh, I forgot to divide by 6, sorry. So it's equal to 10. 10, not 60, 10. So it's equal to 10 kilonewton. So we have Ay minus 15 minus 20 plus NB, it's equal to 0. So NB, it's equal to minus Ay, that is minus 10, plus 15, plus 20. So NB, it's equal to 25 kilonewton. So NB equal 25 kilonewton and Ay equal 10 kilonewton. There. That was the first steps. We find the reaction force. Now we need to divide this structure. Let me copy this. Move it there. Oops. Okay. So no AX. So let's remove the AX. I will clean everything. I will put the AY. We found the AY that is equal to 10. Okay. And the NB, it's equal to 25. And FR, it's equal to 20 times 10, 20, 20. Okay, so we need to split. So, okay, I will never be able to write if I take too much space. Okay, so we need to split in. Do I have gray? Yes, awesome. This is x equals 0. This is when it's equal to 15. This is where there is a moment. This is where there is a beginning of the distributed load. And this is the end. Move this a little bit. Okay. Oh no, let's keep that. And I will draw the shearing force there and the moment there. Let's say this is X. Okay, this is the V of X. And oops, should do in the middle. And this one will be M of X, the bending moment. Okay, so for X equals 0, 2, 3, 4, and the N is 6. So 0, 2, 3, 4, and 6. Yes, that's correct. Okay, so the shearing force, we have a 10. Now I will not solve for the internal force at every step. I will more explain you what's happened with the load. Okay, so that the shearing force 10. After that, there's no shearing force that is applied, so the shearing force will be constant, and this is equal to 10. Now we apply a shearing force of 15, so we need to go down 15, so it's 10 plus 5. Okay, so this is minus 5. Okay, from this point to this point, there's no shearing force that is applied, so it's constant. There, it's a bending moment, so no shearing force. So we keep going. And now we will decrease of 10 kilonewton every meter. So after at 5, we need to decrease of 5 millimeters. So we go to minus 15 and minus 25. And at the end, we go down plus 25. So this is minus 25. So every meter, so from this point to this point, we need to decrease 10, minus 10. So this is, yeah, it's not exactly at the scale, but minus 15 there. And again, between this point and this point, minus 10. So minus 25. And at the end, we go up 25. So that's the shearing, at the change in the shearing forces in the beam. Okay, and now for the bending moment, let's try to understand what happened there. Remember, when the shearing force is positive, the bending moment increase. When it's negative, 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 the moment should decrease, decrease, decrease. Because there's no couple on both sides, okay, there's no moment. The moment at the beginning will be 0, and at the end will be 0. Okay. If it's not 0, we should have a couple that is applied at A or at B, but it's a pin connection and a roller connection, normal force only, normal contact only, so we cannot have any moment there. Okay. So the moment, this one is 15 times 2. So it go up to 15 times 2? No, 10 times 2. If we cut there, the moment will be 10 times 2. So it's increasing up to 20. Okay, so if I solve for the moment at this point, using just so I just cut and keep the left side, this point, it will be 10 times 2, the moment, so 20, and it's increase. Okay. Now at this point, so if I cut there, if I look at the left side, I have 10 times 3 from this one, and I have 15 times 1 on this side. So this one is 30, this one is 15. So here, the moment that stay is 15. So it's decreasing until 15. So this point is 15. Okay. Now at this point, we decrease of 20 kilonewton. No, Do we increase or do we? Okay, so this moment is going down. So if we cut here and we solve for the moment x, we will have the, so now, oops, sorry. We solve for the moment about x somewhere there, okay? So we will have the 10 times this distance, so 10 times 4. We will have, it's in the positive negative direction, we will have the 15 times 2 is equal to 30, and this one is minus 40, and we will have the minus 20. So we have minus 40, minus 20, minus 60, plus 30. Okay, I forget the 5. So we need to increase. I do have 35. What did I miss? 15 times 2, 30, and 10 times 4. So we go, oh, okay, so we will be at 30. So minus times 30 is equal to minus 30. So plus 30 there. So we will be at 30 at 4. Okay, so should be there. Should be at 30 at 4. Okay, at this point. But there we have a 20 Newton gap. Okay, so we have a 20 Newton gap. So we were at, so this is 20, this is 15. Okay, and I need to increase of plus 20. So I should go to up to 35. And now go down up to 30. Yes. So it's still decreasing. It has to decrease because this one is negative. But this couple, okay, there, that is negative, we need to increase the moment x to balance. So it's increasing the moment x, the internal moment x increase of 20 there, like a step. Okay. And now with the distributed load, because the distributed load is a function of x, like a right, okay? This one should be a function square, so it should be something round from there to there, like this, okay, with the x square. And we can solve if we cut anywhere using the distance x and everything. But it takes a long time. What is important, what I want is really the shape of the curve. Okay, so what you have to remember is that when shearing force is constant, the bending force, the bending moment, sorry, increase or decrease, and it's a right. Okay, so this part is a right, this part is a right, this part is a right. Okay, and when the shearing force decrease with the right, oops, so small. So this one is a right from there to there. This one decrease with a function, parabolic function, square. Okay, all those gap there. This one, that's the shearing force 10. This one, that's the shearing force, that's the external load 15. And this one is the 25. And this distributed load is represented by this decreasing curve, right? Okay, and this, we can't see anything else. This 20 kilonewton time meter couple is represented by this step in the bending moment curve. Okay. We have seen also that when it's plus, it's increasing, and when it's, which color do I take? When it's minus, 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 it's decreasing, decreasing, decreasing. Okay, so that's it for the explanation of the bonus function. If you want, you can cut everywhere and solve for in the internal force and bending moment at any point using arcs to find the function of all of them. But this one you will find 10, this one you will find -5, this one you will find 10 for 2, so 5 arcs. You need to solve for this one, you need to solve for this one, and etc. And this one with decrease of 10 kilonewton time meter, so -10 arcs plus something that you can solve for each function. So that's it for this chapter about internal force and the graph. I hope you just understand the links between the shearing force and the bending moment. See you in the next chapter. Bye bye.